Hi, Algebra 1. Here we are in our last video for Chapter 7. It's 7-6, which in your books is page 447, and you definitely need your book today. You also definitely need your calculator. I'm going to be giving you some quick tips on how to use a calculator to do some of our exponent work. And as we study exponential functions, we're not going to be able to go too deep into them under the circumstances. So I'm just going to give you just a very basic knowledge and understanding in how to solve them and how to graph them. And that's about as deep as we're going to be able to go in our distance learning. You'll notice too, as I go through the section in your notes, we're going to go a little bit out of order. So everything is labeled on the note handout if you printed that out. If you didn't print it out, still open the document and read it on your device, because like I said, there are some good things listed and included in there too. Okay, so let's go ahead and dive in. You'll notice the top of your note handout in the beginning of this section, we first define an exponential function. You hear the word exponent in there. You see the word exponent in it if you're reading the word. And so we're going to have an exponent. And so when we have an exponential function, we have y equals a number times a base being raised to an exponent. Now you might be thinking, Mrs. Agate, we have graphed functions with exponents before. You're right, we have. And ours looked like this. If you remember that, we graphed some parabolas and we had an exponent in them. But what do you notice is the difference between this type of function and this? And if you can't see it, you can pause the video if you want to figure it out. Or you could notice right away that in this, what we did with parabolas, my x was my base. And in an exponential function, my x is actually the exponent in these problems. So it's going to change the picture of what we graph. So before we get into some of the practice problems, we are going to graph one together. And you see that in your note handout, and it is also in your book, but I'm going to be working us through it here in the video. If I had this exponential function, y equals 2 to the x power, I want to graph it. And so what I'm going to do is I'm going to make a t-chart. And I might pull this up a little bit closer today. These are the values that I want to plug in for x. I'm going to go ahead and show you all of the work in the math and the algebra involved here. And then I'm going to erase our work and draw a graph. When you move on, you may be able to do some of that math work mentally in your head and you won't need to write it down, which is fine. Now, if this is the case, I know that if I'm going to plug in 0 for x, my equation is y equals 2 to the 0 power. Because remember, my x is my exponent in these exponential functions. Well, now I need to solve it. Going back to day 1, I need to remember that anything raised to the 0 power is 1. So my y is 1. Let's go ahead and also write in, well, what if x was 1? Well, 2 to the first power gives me 2 for my y. So far, so good, right? Let's keep moving. 2, that means y equals 2 squared, because this is my x value. That gives me 4. So far, so good. Now is where it gets a little bit tricky. And my writing is getting smaller, I know that. If my x is -1, that does not mean I get a negative value for y. Remember what that means when my exponent is negative. It means I actually take that base and kick it to the denominator. So -1 is going to match up with a y value of 1/2. All this way at the bottom here, tiny writing. That means 2 to the -2nd power is 1 over 2 squared. So that gives me 1/4. Okay. I guess I still have room here. I'm going to go ahead, draw a quick coordinate plane here as neatly as possible. Now in your note handout, if you printed them out, I included a coordinate for you. So you can go ahead and graph this right on there. Okay, let's use a different color. And let's go ahead and plot some of our coordinates that we just solved for, remembering that these are ordered pairs. This is taking you back a few chapters. So 0, 1, 1, 2, 2. You can see my graph isn't perfect. You're used to that. And then notice what happens once I move into the negative x values. I'm going to have a fraction of 1/2. Negative 2 is going to give me 1/4. Now, you can see I can't be super precise, but I definitely know it's not on my x-axis. So if I were to connect that curve, my exponential function looks like this. Now take a minute and think about what value of x could I plug in so that y equals 0. Think about that. Knowing that when I plug in 0 for x, I don't get 0 because anything raised to the 0 power besides the number 0 is 1. So we actually notice that in this circumstance, I will never have y equals 0. I will never have an x-intercept because it won't ever cross that axis in this situation. And if you wanted to look in your book on page 447, there's a chart there that shows you 4 different exponential functions that are very basic to understand what happens when you add a fraction or a negative sign. And we're going to graph more, but you will be able to see our graph of y equals 2 to the x also on there. So if you wanted to pause the video and take a minute to study that graph on page 447, that might help you be able to visualize these graphs a little bit better. Okay, in the meantime though, I'm gonna move on and we are going to jump to problem number 3. And you can see that written on my board and you can flip ahead there in your book. And let's tackle this one. The same exact process as the last one, but you'll notice in the last one, we didn't have a number here. Well, we did, it was 1, but that doesn't change anything. But now we're gonna change it with adding a 3 in there. And when I say adding a 3, we're not adding, I just put it into the exponential function. It's actually being multiplied. And in this problem, you have to remember your order of operations. Because I know that whenever I have something like this, y equals 3 times 2 to the x, my order of operations tell me that I have to solve this first, because that's using an exponent, before I move to my multiplication. So you have to remember your order of operations when you're doing these problems. Okay, let's dive in. And again, I just chose these 5 values for x. When we were doing linear functions and equations, I said 2 is necessary, 3 helps me understand. In this case, I'm doing a few more just so that we can see where that curve ends up. It gives us a little bit more definition to our curve. Okay, again, this time I'm gonna think through these things, maybe not write everything down, so follow along on your notes. If I plug in 0 for x, it goes right here. 2 to the 0 power is 1 times 3 is 3. So I know when I plug in 0 for x, I get 3 for y. There's my first ordered pair. Let's keep going. If I plug in 1, remember that goes in for my exponent. 2 to the first power is 2 times 3 is 6. When we deal with positive numbers, it's a little bit easier to do mental math. We may need to write some things down when we get to the negative exponents. If I plug in 2, remember that's my exponent, so I have 2 squared, which is 4 times 3 is 12. Okay, so we have some very simple ordered pairs we've already found, but let's see what happens when we go into our negative values. I'm gonna write this one out, because if I have a negative 1 for x, I know order of operations tells me I have to do this first. And I know if I have a negative exponent, that actually moves my base to the denominator. So I have 3 times 1/2, which gives me 3/2, or 1.5. I'm gonna go ahead and write it as 3/2 though, for negative 1. I'm gonna do the same thing This time I'm going to use my eraser, my whiteboard, and plug in, instead of -1, I'm going to do -2 as my exponent. Again, I have to do that first because of my order of operations. A negative exponent moves it to the denominator, but is a positive exponent in the denominator. So I get 3/4 for my -2. Okay, I'm going to clear the work, draw a quick coordinate plane. And again, if you printed out the note handout, you have that in front of you. You can also use graph paper. You may have some of that at home. 0, 3, 1. Ooh, 212 is all the way up here. And then -1 is 1.5. -2 is 3/4. So you can see my curve goes like this. It's a little bit steeper. And it still will follow that pattern of getting really, really close to my x-axis, but never hitting it. Because whenever I have an exponent, I can't get 0 here by plugging anything in. Because x is my exponent, and when I plug in 0, I get 1. So I still will not touch the x-axis here. Okay, I'm going to clear my board. I want you to try a practice problem like this. It is the Got It A under problem 3 in your book, and I'm going to have it up here on the whiteboard in just a second. Now remember, as I'm cleaning off my board, let me talk to you a little bit. Remember, one of the perks of this situation that I'm teaching by way of video is that if there's something that is unclear, you can stop my video and rewind it and listen to it again. And I really encourage you to be doing that, especially with these exponential functions. Okay, if you are still listening to me, it means you have tried this practice problem. This time, we still have this in the form y equals a times b to the x. This time, our base that we're raising the exponent is 3, and the coefficient out front, or the number out front, is 0.5, which is 1/2. So again, I'm going to plot the same points. Maybe I'll just do 0, 1, 2, and -1. You should be getting pretty used to, remember when we plug in 0, that usually is our easiest place to start no matter what we're graphing. That applies here too. If I plug in 0 for my exponent, that becomes 3 to the 0 power, which we know is 1, times 1/2 is 1/2, or 0.5, however you like to look at it. Plug in 1. 3 to the first power is 3. 1/2 times 3 gives me 3/2. So far, so good. Even though we're getting fractions, you guys can handle it. You can hang with fractions. 2 as my exponent. 3 squared is 9. 1/2 times 9 is 9/2, or 4.5. Then make it to -1. I'm going to write that one out. If I plug in -1, 3 to the negative first power, I know is 1/3. 0.5 times 1/3. If you have your calculator, go ahead and plug that in. Or it might be easier for some of you to say, well, we know 0.5 is 1/2. So when we multiply with fractions, we get 1/6. Okay, again, let me clear my work, draw a quick coordinate plane here before we move on to kind of applying some of these exponential functions. 0, let me get my markings on here really quickly. Okay, 0, 1/2, 1, 1.5, 2 is 4.5, -1 is 1/6, which is really tiny and very close, but still not crossing my x-axis. So if I were to connect these, my curve for this exponential function would look like this. Okay, again, if you're having trouble with this, rewind all the way back to the beginning of my video and watch the first 3 practice problems with graphing exponential functions. Next though, we are going to move on to move on, but back to problem number 2. In your book on page 448, there's a word problem there. So I want you to read that word problem. I'm actually not going to read it out loud on the video. This is where the interactive part takes place. You need to read that word problem on page 448, and then we're going to do the math together. So go ahead and do that. Feel free to pause the video. Okay. If you read the problem, you know that word problem in problem 2 is all about beetles. And beetles multiply very quickly. In fact, they have an equation for it, that it's 30 times 2 to the x. And in this case, they told you in the word problem that x refers to the number of weeks. So I'm just going to put that over here, because that means they double every week. And they start out with the number of 30. And these are specifically flower beetles. So if some of you stop to think about what's going on in this problem, it might really gross you out. So don't, just think about the math. Okay, so x refers to the number of weeks. That's what I'm going to plug in as my exponent. But this question specifically asks about how many beetles would there be after 56 days. Okay, hopefully you can still see that. Remember, f of x is just function notation. We have talked about that chapters ago when we talked about functions. We know that we're talking about a function in terms of x. So whatever we plug in here is my x, and that's going to give me my answer. Remember though that function notation is the same as this. It just means we are looking at it in function notation, something that you need to get prepared to see a lot more in your coming math classes. Okay, so here's our problem. Somebody studied beetles, figured out how much they multiply by, came up with an equation for us. Great. We don't need to worry about the science, we just need to worry about the math right now. The question asks, after 56 days, how many beetles will we have? Well, x, I'm told in the problem, refers to my number of weeks. Well, 56 days does not mean I'm going to plug in 56 here, because that would be after 56 weeks. That would be over a year later. Ooh, be a really big number. Blah. So let's make sure we're reading carefully and solving the problem that's being asked. If it's after 56 days, and I know there are 7 days in a week, that means I'm really dealing with 8 weeks. So I'm going to go ahead and take that 8 and plug it into my x. Remember that exponential functions have my x as my exponent. So I'm going to rewrite that. 30 times 2 to the 8th. Order of operations tells me that I have to deal with my exponents first. So 2 to the 8th is the math that I'm going to do first. Now I know that that means I am multiplying 2 by itself 8 times. And I could do that math. 2, 4, 8, 16. I could do that all in my head. I definitely could. But I also want to I want to pause this problem for just a minute and talk about how to do this on your calculator. If you brought your scientific calculator home from school, you will see on your calculator a button that looks like that. It looks like a caret. Sometimes English teachers, maybe Mrs. Agate, uses the caret to use an insert symbol in your editing of your papers. That's what that means. In grammar, in math, a caret means we're raising something to an exponent. So if I plug in my calculator 2, use my caret button, 8, equal sign, that's going to tell me what my answer is. And it is 256. If you didn't bring home your scientific calculator and you need to use the calculator on your phone or computer, I also want to show you this button. You're going to see X to the Y. That looks a lot like the button we use on Khan Academy too. You're going to use it the same way. That means I'm raising my first number to the power 8. 256. So now is a good time to try and feel comfortable on whatever calculator you're using at home, how to raise a number to a power so that you don't have to do all this hard math. Now, granted, 2's not hard math, but moving forward, you might have different numbers. Okay, that was a little side note. That's how to do it in your calculator. So we now know what 2 to the 8th is. It is 256. So I will plug that in, following my order of operations. Now I'm ready to do my last step of multiplication, and I get 7,680. That means these beetles multiply at that rate, and there will be 7,680 of them in the warehouse after 8 weeks. It's a lot of beetles. Okay, I want you to pause the video right now and try the Got It problem under number 2 in your book on page 448. It's another word problem, just like this. You pause the video, read the word problem, set it up, plug it in, and then restart once you have an answer. In the meantime, I'm going to clear my board and write down the math that we need. Okay, here's the math that we need for that word problem. That word problem is talking about rabbits. And rabbits triple their population every half year. Ooh. And somebody, again, studied rabbits and came up with this function for how rabbits multiply. They start with 20, and they triple every half year. Remember, this is function notation. It just means the same as having a y there. The question is asking us, after 3 years, how many rabbits will there be? Well, we are told in the problem again that my x refers to a half-year period. So just like our previous problem, we didn't plug in 56. We had to figure out how many weeks that was. In this problem, 3 years. We're not going to plug in 3 years because it's based on half-year periods. So there are 2 halves per year. So our x value that we're going to use is 6. There are 6 half-year periods. So I'm going to plug that in. 3 to the 6th power. Again, you can do that math. Some of you can do it mentally. I know it. Some of you can write it out and solve it no problem. But we still want to be comfortable using our calculator. So find your caret button or your x to the y button. And you would type in, because of order operations, you have to do this first. 3, whichever button you're choosing, 6, and you would get 729. That's 3 to the 6th power. Then we're able to multiply that by 20, and we would get 14,580 rabbits as our answer for that problem. Okay, again, if you're having any problems with these, rewind my video and watch it again. Or don't forget about the resources on Khan Academy, where there are also videos there, which leads me to remind you to look at the suggested problems for your book. Make sure you're attacking a broad range of those, especially the higher numbered ones, because my problems may look a little bit more difficult than Khan Academy based on our textbook. And today's assignment on Khan Academy isn't going to be practice problems. It is actually going to have you watch a short video. You'll see that under your assignments on Khan Academy. You'll see it on your note handout and in RenWeb. And I think it's a 5-minute video. It's very short, but it's just another way to learn about exponential functions and graphs and get just a different voice teaching you this lesson. Okay, don't forget about our test for Chapter 7 is coming up at the end of this week. And if you are ahead of schedule, don't forget our Zoom meeting on Tuesday where I'll go over all of the details there for your chapter test. Okay, have a great day.